rational expressions. So rational expressions, it doesn't have anything to do with it being like rational, you know, like the word rational, like we use it in everyday life. Rational actually means it's more to do with the word ratio there. Or a ratio means something over something. It really means fractions, right? We're really going to have this like these polynomials that are set up as something over something. That's what a rational expression is going to be. Okay, so these are all examples of rational expressions, right? And one kind of issue with these things is that if I go, let's say 9 divided by 0 and put that into my calculator, what do you get?
Or error.
Yeah, you get an error.
Siri just makes fun
Yeah. So yeah, you can't divide by 0, right? It's like saying if I had like 9 cookies and I'm going to divide them into no groups, how many cookies does each group get? Right? It's like that's kind of like a nonsense. It doesn't even actually make sense at that point, right? It's not like it doesn't even work, right? So you can't divide by 0. What about this though? What if I had? Oh yes, that was like not defined or does not exist. What if I had 0 divided by 9? What would that be?
you can't divide 0 in 9 groups.
You actually can. This one's fine. 0 divided by 9 is still just 0.
Oh. Wow.
Yeah. So get these. You just can't divide by 0. So that's going to be when we start looking at our undefined places or restrictions. I'm going to be calling them here. That's always that we just can't be dividing by 0. That's like pretty much the only restriction that we're going to have in this unit. Yeah. So let's kind of go down. Look at some examples here. So let's say that we had an expression like, we can look at that one. I'll make up a new one here. Let's say we had x. Ooh, that was weird. X minus 2 over x plus 3. And I said, okay, what are the non-permissible values? So, and let's maybe back up a bit here too. This is what's called an expression. And that's different than an equation. We're going to be doing equations here in a bit, but an equation would be like this. It'd be like x minus 2 is equal to x plus 3, and that's all equal to 4 or something. Do you guys see the difference here where there's an equal sign? So that's what's called an equation. And if there's an equal sign, then that means that there's some actual number of x that would make this thing true. So in this case, I'd be solving for x. But when it's written like this with no equal sign, this is what's called an expression. And an expression, I can put any number in for x, right? Like I could put like 1,000,000 in for that. I could put 5 in for that. I can put like anything I like into this expression, right? But I can't put anything I like into this equation because it might not be true. It might not actually equal 4. Does that make sense? Okay, so first what we're doing expressions. So looking at this one now, I have to say that, okay, x can be any number in the universe except for one number. There's one number here that x would not be allowed to be. Can anyone tell me what number x, and this is how we write it, we say x, well technically you'd write this expression and then a comma, and a comma in math means where. So x minus 2 plus, or over x plus 3, where x cannot equal, so it's like an equal sign with a line through it,
2.
cannot equal 2, you're thinking?
Yeah.
So I think what you're going with is that if 2 was right there,
Oh, it'd be -3 because it can.
right, it's fine if the top is 0, right? The top is allowed, the numerator is allowed to equal 0, the denominator is not allowed to equal 0. So x would not be allowed to equal -3. And do you guys kind of see why that's true? Like if I threw a -3 in there, that'd be -3 plus 3. That would make the bottom 0. And you can't divide by 0. Does that make sense? Okay, let's do a little bit tougher one now. So let's say if we had x over 3x minus 4. And it said, okay, where x, and you guys would have to figure out what x is not allowed to be. This one's a little bit tougher to see now, eh? Like what x is not allowed to equal. So what we should do here is say, okay, well, I know whatever this comes out to, right? Whatever 3x minus 4 comes out to, it can't be 0. So let's just make ourselves a little equation for a second. Let's say, okay, I know that 3x minus 4 cannot equal 0. And let's just treat this like a little equation that we got going on. So let's get x on its own. So we got to do some algebra now. So I've got, like, I need x on its own. So I'm going to get rid of that 4, the negative 4, and that 3. Which one's got to go first, the 3 or the 4? The 4, right? It's like farther away, I was going to say, right? So we're going to add 4 to both sides. So plus 4 plus 4. So then we've got 3x cannot equal 4. And then what's the last thing I would do to get rid of that 3? Divide by 3, yeah. So divide by 3, divide by 3. So it turns out that x cannot equal 4 over 3. So that's my non-permissible value. So you'd say x cannot equal 4 over 3. Yeah? Okay. And this would make sense, right? If I threw 4 over 3 into this, that would come out to 0 on the bottom. Right, that's what we just found out. Yeah. Good? Okay, I'm going to give you one. Well, no, that's probably good. You guys can practice those now. Okay, the next part, what we're going to do is we are going to simplify some rational expressions. So, simplifying a rational expression, let's just kind of use this simple example that they gave us. If we had like 2x over 4x squared and it said to simplify this thing, this is where we're actually just going to start like canceling things. So what we're going to do is just look at the numbers by themselves to begin with. So I got 2 over 4. Does anyone know what 2 over 4 would simplify to? So careful on this one. Yeah, a half is what it would end up being, right? Like I know what you mean by 2 there, but it would be a half because it would end up, and we're right underneath. It's like, so we'd have 1 over 2 like that, like divide the top by 2 and the bottom by 2, so you get a half. And then write this line, just keep writing the line, right? Like just like extending it there, because now we're gonna have like an x on the top or on the bottom. Okay, so that 2 is in the bottom and the 1 is in the top now when we simplified that. Yeah, so now with the x's, what do I got going on here now? There's gonna be, yeah, you can think about with your exponent laws if you want. It gets I like to do it a little bit different though, but I'll show you why that works. If you had x to the 1 over x to the 2, what do you do with the exponents when you're dividing? You subtract them. So that would be 1 minus 2. That would be x to the negative 1. Yeah, that's actually right. Like it is x to the negative 1. But do you guys remember that a negative exponent would really be the same thing as 1 over x? You guys remember how we like flipped it to the bottom? Okay, now that I just want to show you that that works. I think we can do it a little easier than that though, a little bit more intuitive. So if we had, let's say, here I'm just going to write it out again. If we had x over x squared, well, that's the same thing as x over x times x. Now we can kind of see a little bit clearer what's going on here, right? I can just cancel one of those x's on the top with one of those x's on the bottom. And do you guys see what I'm left with? After I cancel that one on the top, I've just got 1 over x. You guys good with that? Let's do another one. Well, here, we'll finish this one. So that was, in the end, 1 over x, so that would just be on the bottom. So in the end here, we'd have 1 over 2x.
So there's no x on the top?
There's no x on the top. It canceled, right? And when you canceled it, it's not that it's 0, right? When you divide these things, you've got 1 still. Yeah? Okay, let's do another one. Let's do like a, let's just say we had 3, let's say x to the 3 over 4x to the 5. And we were going to simplify this. Actually, you know what? Just using what we just did. I'm going to pause it for a sec. So let's look at this one. So here, you know what? I'm not going to put an equal sign too because I find that that's confusing sometimes. When we do math, write it below it, like this is an expression, and then like you could put this is equal to something else, but I find when you do that, people confuse it with equations. But just write it below it now. So then, I'll look at the numbers first. 3 over 4. Is there anything I can do there? No, it has to stay as 3 over 4. And just extend that line just like it is right now, right? And then the other way I kind of look at this is it's almost like there's a battle going on between these 3 x's and these 5 x's, right? So it's a battle between the numerators and the denominators, right? The top and the versus the bottom. If there's 5 of these guys and they go to battle with 3 of these guys, how much is the bottom going to win by? 2. So it's got to be x2, x squared, right? The bottom wins by 2 there. Really what's happening there, though, just one last time, it'd be like 3 x's on the top and 5 x's on the bottom. 3 of those x's cancel with 3 of those, and you'd have 2 x's left over. Does that make sense? Okay, so that's how we simplify those. Now, the next one that we're going to bring up, this is the last one for this lesson, is we have to do factoring and simplifying, right? So if we get an expression, I'll just redo this one. If we get an expression like x squared minus x minus 2 over x squared minus 3x plus 2, and we want to start canceling out what we can, first step on any of these ones is we factor it. We're going to be doing that all the time. When we simplify, when we multiply, when we add, the very first thing we always want to do is kind of factor it to see what we're looking at. So let's factor the top. So that'd be so the top here, I could just throw down my brackets, x and an x, and I'm looking for numbers that multiply to 2 and add to 1, right? Because there's really a 1 there. So numbers that multiply to 2 add to 1. It could only be 2 and 1, right? That's the only thing that multiplies to 2, right?
So smart.
I got distracted.
Okay, so they have to multiply to a negative 2, though, right? So one's got to be negative, one's got to be positive. Which one's got to be negative? The 2, right? And that makes sense. Negative 2 plus 1 would give me negative 1. Okay, so the top is factored. And then on the bottom, we'll factor that one now, right? Now we're looking at this one. We're looking for numbers that multiply to 2. All right, you guys got this? 2 and 1. Okay. So 2 and 1. And then, okay, so how's this going to work now? We're looking for numbers that multiply to positive 2. So there's 2 ways to get a positive, right? They could both be positive, or they could both be negative. People always miss this one. They like get confused by that, right? They could both be negative, which would work out great, because if they're both negative, negative 2 minus 2 is negative 3. So perfect. Now, this is the part I like the most. So once you get it set up this way, once you factored it, you kind of done the hard part, and then you get to just start canceling things out, right? Because we got x plus 2 and x minus 2 and x minus 2. We get to cancel those. And that's it. And we're left with x plus 1 over x minus 1. Now, one thing I just want to bring up here, so that's what our answer would be, right? So it'd just be x plus 1 over x minus 1. What would our non-permissible values be, by the way?
1.
So you'd say x is not allowed to equal 1. Anything else? It would actually still be 2 as well. Because we have to look at it, because this was the original equation, right, before we canceled things out. And that had x minus 2 in the denominator, right? Because if we had x equal to 2 there, then that would be 2 minus 2. That would make this section here equal to 0. And then anything times 0 would just be 0, right? So if that's 0, the whole thing's 0 in the denominator, right? So it's also not allowed to equal 2. So it can't equal 1 or 2. Does that make sense? When you do your non-permissible values, it has to be before you cancel things. Okay? And then just last one here too. Why couldn't we have just went, okay, x squared, cancel with x squared there to begin with? That's what people always get a little confused on with this. And I'll just give you maybe a little bit more clear example, like an easier example. Let's say I had x over x plus 2. And I was like, okay, perfect. I get to cancel this x with this x.
Oh, because there's something that denominator.
Yeah, well, and the reason why this doesn't work is because when we had x over x plus 2, that really meant it was x over, like, it's over the x, or sorry, the 2 is under there too, right? It's like we were pretending the 2 wasn't involved in that at all. So we just canceled this and said that was good. But yeah, we can't do that, right? Another way, Larry, let's write it the other way. If we had x plus 2 over x, right, and this might be easier to think about, because if we had this and you just tried to cancel it, then really though, this expression should have been x over x plus 2 over x, right? That's what that means when you like write it out again. So then if I just canceled these ones, thinking that was good, it's like I was pretending that this 2 wasn't also over the x, right? But it was. Does that make sense? So we can't just cancel those things. The only time you can cancel these is when you factor it. We factor it because now it's this thing times this thing, right? So it's like 3 times 4 and 5 times 4. So all of this gets to cancel out with all of that. So you can only cancel after you factor. So please don't make that mistake, right? That's a common mistake.